So with me on stage, I have Sushil, who is the CEO of Berkeley Marine Robotics. I have Adil, who is the executive North America West Coast, that doesn't seem like the right title, MarineTraffic. And then I have Kortney, who is the founder and CEO of Blue Ocean Gear. And magically on screen as the fourth speaker will be Gavin Allwright, who is with the International Wind Ship Association. And they are speaking to ocean data, wind propulsion, and swarm technology. So I guess we just put together everything that didn't quite fit all onto one panel. So I think it'll be a very exciting discussion. So with that, I will hand the mic over to Sushil. Get us started.
All right, do I have a tale for you? Let's see. Oh, we're already up here. So, as you can see, my name is Sushil Tyagi. I'm here representing Berkeley Marine Robotics. And as the name suggests, it's really were a bunch of PhDs at Berkeley who was thinking of putting lasers on the heads of sharks. And that seemed like the thing to do till they heard about something called biofouling. And in the beginning, it really seemed like some kind of a sports term, like in a soccer, probably the ball hits you at the wrong angle and you have an unfortunate biofoul. And we really thought but then it seemed that biofouling is really kind of fascinating. It's been around for thousands of years. Since ships have been coming into the Phoenician times, there was always biofouling. Things grow at the bottom of the ship. It makes the ship get slow. It's always kind of gets taken care of somehow. Only in modern times is leading to new problems, because as the biofouling happens, the ships get slow and the driver has to crank the gas on it, because now the ship has to get there on time. It's not like the Vikings who could just show up a couple of weeks late. So as a result, this issue of having to make it on time and cranking that gas is where the problem lies. Now you have increased fuel, you have increased emissions, simply because you were not tracking what's going on underneath. And so now let's look at this. The IMO just had a report a couple of months ago. We presented in London at their conference. And really what they're saying is that right away, the moment a slime layer started to build on the ship, you have 25% to 55% increase in fuel cost and emissions, almost correlating together. And that happens very, very quickly. Now you have to know it doesn't always happen. It could be colder waters, it could be different kind of speed. But you have to know that if it happened, this is costing you that much. As you can see, in global fleet, we just simply kind of estimate, this starts looking to tens of billions of dollars of fuel just going in and hundreds of millions of CO2 tons being emitted simply because there was biofouling that should have been monitored and wasn't monitored. And this is like a quick hit problem. This doesn't require having to come up with a fantastic fuel or some amazing thing. Just manage the bottom of the ship and you could make this happen. On top of it, now we have the issue of invasive species. This stuff, and I'm not talking ballast water, when you have biofouling coming underneath the ship, it's bringing all kinds of guests over. And now you would think that given between the fuel and the emissions and the invasive species, wouldn't this be a great idea to keep these ships clean all the time? But no, things are actually not that straightforward. Most of the port will tell you, don't clean here, please. No, do not do this. And also, many a times, the coating and the paint that's gone on the ship, they have told you not to touch it. Doesn't matter what's going on it. On top of it, if you simply just wanted to clean it for cleaning's sake, it's costs. And it costs in delays. If you hold up a ship to clean when it didn't need to be cleaned and you didn't know, that's going to cost you bigger than what the fuel saving was going to be. So the issue then comes up is this. You have problems of trying to clean too early, and you have a problem if you clean too late. There is obviously a point in time when it would have been the best time. It would have been, that's when you optimize your costs, plan your schedule. Wouldn't this be great? Wouldn't it be good if we knew that? Except nobody knows. Nobody knows when that time is, because what really happens is this. You have divers who go down there once in 6 months, sometime once in a year. And they take hours to take essentially subjective narration of what they are seeing. This report then is sometimes arrives after the ship is long gone. And then even if you wanted to act on it, it's going to take you hours to review this and make another subjective judgment. So when we started talking, when we were doing National Science Foundation research, we started talking to the big industry shipping lines, and they kind of said, if there was only a way that every time the ship came into a port, it just got scanned, the bottom of it just tricked. But it has to be fast. It can't be hours and days. If it was just within minutes, somebody scanned it, and I had this data, and on which we could make a better prediction of when to clean it, when to hold it, optimize cost, optimize schedule, wouldn't that be great? That kind of doesn't exist. But we said, hey, we were thinking about a swarm of robots talking wirelessly with lasers underneath. Now let's bring that into play. What we are saying is, if we had autonomous devices, nobody was operating them. If somebody's operating them, it's worse than divers. At that point in time, now you have an expensive device, an expensive operator. You really need things that are doing things on their own. They can follow the hull well line, and they can scan a ship, and because there are multiple ones, they can cover it in one go, and we have been doing some of these field tests. And you would say, if you do it fast, and it's reliable, and it's not a guesswork, and it's not like just a GoPro on a stick, if it's real data that can also help in prediction, now we got something. Now we can really reduce those hundreds of millions of tons of CO2 in a pattern. Now, I'll give a few seconds of swarm tech primer. Essentially, when we talk about a swarm, what we're talking about is how do small robots somehow work as a group? And a very simplistic way is like a leader and a follower. Usually it'll be like one doing everything and the other one is following. But that is really kind of doesn't work underwater. It'll take too much power, and if you lose the master, then the rest of them are useless. So what's really done is what is done by the fish and by the birds when they're together floating. That's called a consensus driven, that they have a consensus among each other. They kind of know where they should be. The group kind of knows where you should be, and they tell each other. And then similarly, the robots are adjusting to each other and get it. Second thing they do is formation control. What we are doing is when we get near a ship, they're not just in a big group, but they're going to have a sort of a formation that is going around the ship and making a form that they maintain. Now, this would be all very simple in the air, actually, because you just use radio frequencies and they talk to each other. In the water, there is no radio frequency. There's no GPS underwater. The moment the thing goes underwater, it doesn't know where it is. Also, it cannot really talk to any of the other ones. The radio frequencies die off after a few inches. So unless they're all kind of huddled together, they really don't know about each other. That's where we come into the using a wireless method. The wireless underwater through lasers is extremely cutting edge tech. It's like really trying to bring something that's so cutting edge to an ancient problem and a global problem to solve it, because it can be done. Otherwise, you have these ROVs with a bunch of cables and tethers that are going around. They can't really form a swarm that way. So it has to be that there are no tethers and there's a proper swarm that is safely operating. It can go around obstacles and it can do it within minutes. So, sorry, I just went a little bit too far. Okay. What I would do is I'll just quickly go to, I think it's moving only in one direction, seems like. Can you rewind a little bit? Okay, but I'll just go with this, that what happens here is that what we are proposing is something more reliable than just pure kind of prediction based on weather or something on which you cannot lay hundreds of billions of dollars on that kind of methodology, nor kind of relying on something that is just so manual. What the lovely thing about this is that with the swarm and the wireless, you've enabled the system, but what has really happened is most people who love this is who thought will be our competitors. We thought divers would say, wait a minute, you are suddenly making us redundant. No, divers love this. Divers hate doing inspections. It makes them no money. They would rather be welding and repairing and properly cleaning. That's the real high margin, high growth job. They are looking to make immediate partnership with us and say that, you do the inspection, automate the inspection part of it, get the data out there. When it needs cleaning, call us. That is what the real thing needs to be. So what we are really talking about here is that we started the research, And then we had some grants from National Science Foundation. We started to do field tests, doing sort of a mini swarm and around stationary vessels, and then start to incorporate the laser signal into it. And then we are moving into doing the field test up there. We believe with this, as the CII penalties come onto the ships, and if invasive regulations start to come in, the need for this data, the California Land Commission or any other authority would increase. And if we have a tool sitting in the port and the port supports it, then suddenly you will have everybody benefiting from this data. That's the beauty of it. It helps the ships, it helps the divers, it helps even the regulatory agencies, because they can mandate a use of certain tool. And eventually, this kind of technology can go even help in the dual use in the defense, because if you have underwater swarm that can do a certain task on its own and communicate wirelessly, you could be monitoring a port, you could be monitoring a channel, have almost an underwater wireless mesh network. So we feel this is something we can do to help create a real solution to a burning pain point tomorrow, at the same time help the climate, and also hopefully contribute to the security of this country. Thank you.
All right, we're going to switch gears a little bit, literally to fishing gear, and the role of fishing gear can play in ocean data. So I'm with Blue Ocean Gear, and we provide smart buoy technology for commercial fishing fleets so that they can track their gear out on the ocean. But besides just tracking gear in the ocean, it can also be used to provide ocean data. But first, why do we track gear out in the ocean? Because right now, we're not tracking gear. And what happens is that a tremendous amount of gear is lost every year throughout our oceans, and the impacts are devastating both economically as well as environmentally. From an economic perspective, about 700,000 tons of gear is lost in our oceans every year. And that's a significant cost for the fishermen to replace. It's between 10 and 30% of their gear lost. In some places, it's even up to 80% if there's high hurricane activity. But as we started working with commercial fishing fleets, they were saying things like, well, I don't necessarily lose my gear, I just have a hard time finding it. And what they meant was that they would eventually find it, but it would take them hours. If you've ever seen Deadliest Catch, the ocean is a very volatile place. So fog, inclement weather, high seas, strong tides, that can all play a role in how long it takes for a fishing fleet to find their gear. There are also very lucrative fishing fleets at risk of being shut down because of ghost gear and marine mammal entanglement issues. But from an environmental perspective, that gear continues to fish. Everything that's captured dies and becomes bait for more fish to become captured. It's a cycle known as ghost fishing that can deplete fishery stocks and really have a devastating impact on marine ecosystems. It's also, fishing gear is one of the largest sources of ocean plastics. That very few people know this, but a recent study from the Ocean Cleanup showed that between 75 and 85% of the Great Pacific Garbage Patch comes from fishing-related sources. So we've developed our smart buoy system. These are GPS tracking buoys at their core, and this lets fishermen know where their gear is at all times, and they get an alert if something anomalous has happened, like it's moved too far beyond a certain threshold. But we also started putting additional sensors on the buoys. We found that the fishing fleets needed to know more than just where their gear is, but what was going on. So being able to differentiate between a storm washing gear away, a marine mammal entanglement, a boat dragging their gear, strong tides or strong currents dragging it under, all of this impacts what their response is. And so as we added sensors, we were able to create a more of an eyes on the water or a superpower for the fishing fleets now to know what's going on with their gear. And the data is sent via either radio or satellite to our cloud database. We have multiple different ways that the fishermen can interact with that data. We have a mobile app, web interface that has all of their data, or an API. We have text alerts for things like your gear's been set or hauled from the water. Some fishermen are using this to detect gear theft. And then we also have the ability now to integrate with their onboard chart plotter systems. And so these are their GPS systems that show them usually where their boat is. Now they can actually see where all their gear is. And to roughly quote one of the fishermen that we work with, it lets them fish like it's a sunny day, even when it's an extreme fog out. So then how can we use these buoys to not just tell fishermen where their gear is, but also create more of an environment from this ocean, the ocean sensor data that helps both the fisheries as well as other ocean industries. So I'll talk about a few different ways that we're looking at this. This image here is of a GPS chart plotter, and it shows the nautical maps, and they have weather overlays. And normally it just shows where their boat is, but these little scribbles up here actually show where a couple of their smart buoys have traveled. Out in Alaska, this can be about a kilometer radius every day, and some of the smaller fisheries it might be less. But that's a significant range for the buoys. Now, one of the main ways that gear is lost, one of the big issues out in the ocean is gear conflict. This is where vessels that may or may not be fishing, but other maritime vessels transiting through an area of high density fixed gear can get tangled up in the lines or the nets or the traps. And so that can cause damage to the vessel. It usually ends up in the gear being cut loose, so nobody wins. So being able to share this information of where there is gear with other vessels can now let them plan their routes around that and avoid gear conflict. This picture is of a mussel farm, an aquaculture farm up in Nova Scotia that has been using the smart buoys. Aquaculture runs on data. And so for this farm, particularly the sea surface temperature, it lets them know when to raise and lower their pens, when to harvest. It happens to be in an area of high vessel traffic, so they do also need to keep track of where their gear is. But as we add more sensors to the buoys, they become more of a player in the aquaculture realm as well. Now this picture is from a snow crab fishing boat up in the northern Bering Sea. That's ice that's formed on the rails. A lot of vessels tend to operate up near the Arctic sea ice, and when ice forms on the rails of their boat, it actually becomes a safety issue. If the crew can't keep up with getting the ice off, and literally they use baseball bats to hack the ice off, they can't keep up with it, the boat can actually capsize. And actually, an incident like this happened a couple of years ago where they lost a crew. Very tragic accident. So we're looking to help with sea ice behavior prediction. Why do boats end up operating in that area? Well, for snow crab, the crab like to hang out there, so they fish right at the edge of the ice shelf. And then if the sea ice prediction is off and they're back in port offloading, the ice can come down and slice off all their gear, again, leading to more gear loss. So just earlier this week, we now have a signed MOU with NOAA, National Weather Service. So data from fishing gear buoys in the Bering Sea, that sea surface temperature data will be shared with the National Weather Service to help with sea ice forecasting and hopefully help predict more of the behavior that goes back and benefits not just the fisheries operating in that area, but also any other vessels operating there as well. Right now, we've delivered about 700 buoys to customers all over North America, mainly focused in that area right now. And you can imagine now, as we get a higher density of smart buoys out in the water, this becomes a very hyper-localized coastal data set, with spatial resolution that you're not going to get with other means of collecting ocean data. And so this can play into some of the other ocean data sets that are out there in a very complementary way. And that is all I had for now. Thank you very much.
Hope everyone is still awake. I know it's been a long day. My name is Adil. So on the topic of ocean data, the ocean is big. So with a big geographic zone, there's big data that's out there. And with our topic of driving data towards sustainable goals, how can one utilize such data to make it valuable for reaching an objective? And I've been humbled to hear from a lot of you that you are aware of MarineTraffic, that you have used it. I just thought It's the afternoon. Everyone's a little tired, but let's have a little fun. If you want to download it, if you don't already have it on your phone, by all means, I have both QR codes up there. The app is not only the only thing that we do. We also have data services via APIs. We have an online dashboard and raw data that is accessible, and that complements many different use cases in many different sectors. Just a little background about MarineTraffic. We're a maritime intelligence platform, and we've just celebrated actually yesterday our 15th birthday. And with all those years of hard work, there's a lot of data that we've been able to accumulate, and a lot of different scenarios, use cases, projects that we've been able to support and been involved with. And a lot of it also goes towards sustainable goals, whether it is for the global maritime fleet or it comes down to a logistics issue. AIS itself, it is you call it a legacy system. It was designed back in the 70s as a collision avoidance system for vessels. And it allowed the seafarers to have visibility based off of a range and bearing if there's other vessels within my vicinity to reduce risk of collision. Now, at that time, there wasn't really a means of thinking outside the box. What else could you do with the data? But when you do harness that data, and we'll talk a bit more about what is included in that information, you can really create amazing visuals and insights. And this data has been used to support various use cases, from security to fishing to energy and protecting environments, and even just getting situational awareness outside of a specific geographic zone. So in this screen here, this is just typical data that tends to come off from vessels, and vessels are required to have an AIS if they're over 300 gross tons and for commercial usage. And with that information that is transmitted for authorities to understand the intent of a vessel, the crews would ideally input where are they coming from and where are they heading to, and other characteristics of that vessel's voyage. So speed, its course, its status, if there's any draft information that's being reported that can also be captured and captured for various types of vessels. And from our standpoint, we enrich that data from our own intelligence. And in this scenario, this vessel is going from one location to the next, and that is a voyage. And that voyage has a specific route that it'll follow. And historically looking, we can cross-reference, is this vessel taking the usual great circle track that other vessels of a similar type, similar route have taken? If not, what is the reason? Could there be other data layers fused with this information to provide a response to that deviation? And when we bundle all of this together, we go into the analytics, the insights of what is possible with the AIS. And some of the ways that we've been able to enrich it is through geospatial geofencing. We've done a lot of work in geofencing ports, terminals, anchorages themselves, to understand the health of a region, of a port. What is this capacities? How busy is it? How congested is this place? How many vessels are on their way? That we can help forecast and predict whether there could be additional backlog. It also helps to enrich data that's out there, but not necessarily accurate. So if you can have a supplement data source to verify an original source, such as in logistics cases, carrier data. Carrier data can be delayed, it could be inaccurate, but when you utilize something like AIS with geofencing, you can say in real time that the vessel has indeed, in fact, arrived versus it actually have arrived, or carrier stating it arrived 13 hours earlier. And in this slide here, that predictability, since we have data that stems years and looking at how vessels maneuver throughout the world, we see these sea lanes of communication, these trade lanes. And based off of those routes, we can start to make predictions. You could say these route forecasts are much, or these routes should be taken in this scenario versus this route that could have been an alternative. So these types of insights can help drive ships to sail just in time, reduce speeds, or take a different route based off of weather routing, and to assist with fuel savings. In a general sense of MarineTraffic's capability of visibility globally, today we're tracking over 300,000 vessels live. From that, we are collecting hundreds of millions of positions a day and millions of events that correlate to those vessels' movements. And with all that data combined, we can produce the global maritime world and how the world functions as an economic engine. And this is just a screen grab, just a few hours ago actually here, just what's happening. And when you're on the app, you'll notice the different colors represent different types of vessels, so you could drill down to see how that specific market is operating. And this is a screenshot of activity just south of Nantucket, where we know that the US is going to be embarking on offshore wind projects. So we can already see a lot of the survey work that's being done out there in that region to prepare for those installations. In this session, I want to talk about a few use cases and how the data from AIS has been able to prove ways that we can be more conscious of our marine life and also of the environment itself. And there is a use case where a program called Blue Whale, Blue Skies. And it was embarked upon with collaborations from NOAA, various air quality management throughout the state of California, various ports who also signed on to this program. And the idea was to essentially reduce vessel speeds along the California coast to reduce impact and on whales so that there's less mortality rates. While at the same time, you reduce speed, essentially you could reduce emissions. And this program helped to incentivize a lot of the shipping companies, all the big fleet owners out there. And they could sign on voluntarily, and they could get graded. And at the end of the season, depending on how they performed, there would be incentives that would be provided. The program itself focused on California's coast, and it takes place every year since 2014. And the criteria is that if a vessel is transiting within these specific zones, that the speed should be at 10 knots or less, if it's possible. And that certain seasonalities, the whale migrations are more. And looking back from the AIS to determine the performance of these vessels, which were owned by the carriers, pre-VSR, we can see that the majority of vessels were moving above 10 knots. So they really weren't conscious or aware of, we're not going to do this. And if we look the next year, it flipped. Most vessels went below 10 knots. So there was a great percentage of participants that actually followed that program's rules. And they, of course, were awarded. And this was the awards from last year of the carriers that performed best. And of course, it's a lot of the major players that we're all familiar with. But that helps to show that, in the economic engine that moves trade, there are incentives for even the big conglomerates to say, yeah, we care about the environment, that this program is reasonable for us, and that we will do that to protect the marine life. And at the same time, we can help reduce emissions. And this was the statistics of all those results throughout the years, and most notably 2021 and 2022. You can already see just the number of vessels participating, but also the tons of reduction of the greenhouse gas emissions. So the numbers speak for themselves, and a lot of this was verified via the AIS. And actually, since I have a few more minutes, or just about a minute, the future. So how else can we start to think long-term for a sustainable future? And we've embarked on a project to introduce new hardware that will help drive data out from vessels. Vessels, on average, can generate over 20 gigabytes of data per day. Now, how do we harness that? And of course, there are many sensors, but we've taken a very vendor agnostic approach. Doesn't matter. We can definitely find a way to capture all that information from the propulsion, the machinery, the cargo control rooms, and the bridge to then feed out into the world, have a virtual navigation bridge, but also at the same time, from the perspective of weather, if you have the capability to get weather live on the surface, on the ground, and of course with buoys you can do that, but imagine a world where all vessels were a mesh network and we had live data being fueled into the models that we currently use today. We'll be able to predict weather more efficiently, more effectively, in more real time, and then allow vessels to navigate more safely and more efficiently. So that will help reduce a lot of emissions and fuel usage and make the world a greener place. But I think that's my time.
Awesome.
Thank you.
Thank you. All right, so now that I've mastered, I turned this off, not microphone management. Now that I have mastered 3 speakers, we added a 4th virtual speaker to this panel just to throw off my time management skills. So I think you have a video to play for us. Yes? Yes. Again, this is Gavin from the International Wind Ship Association. Thank you.
Good afternoon, everyone. Sorry I can't join you today. Unfortunately, I'm stuck over in Tokyo. But I'd like to welcome you all to the Decade of Wind Propulsion. And my name is Gavin Allwright, and I'm the Secretary General of the International Windship Association. And today I'll be running through, just to give you a little update on an exciting area of development in decarbonisation of shipping, which is the provision of wind propulsion for commercial shipping. So to quickly introduce the International Windship Association, we're a group of over 150 commercial companies who are members and registered supporters. That's the active group, and then we have another 50 or so supporting actors as well. And our main role is to help facilitate and ultimately deliver wind propulsion for commercial shipping worldwide. Some interesting news happened at the beginning of this year. We had the Financial Times and The Economist both indicated that wind propulsion on commercial shipping was one of the 22 technologies for 2022 to be keeping an eye on, and these are emerging technologies. The International Chamber of Shipping actually chose to use a wind ship on its 4th propulsion revolution report recently, and they represent the vast majority of shipping interests in the world. We also were given or awarded consultative status at the International Maritime Organization, which is the UN body which oversees shipping interests and maritime aspects worldwide. And finally, we had a historic moment just at the end of last year where the 2 largest wind assist vessels, a very large crude carrier and a very large ore carrier, both over 300,000 deadweight tons of shipping, actually passed each other off the coast of Durban. So quite a historic moment. Now, what are we talking about when we talk about the direct application of wind power? Well, it's pretty easy. It's moving a ship with wind. But from an energy perspective, if you put the wind through a turbine, transmit that, mine it, if you like, mine it, refine it, transport it, bunker it, and then store it on board and put it through an internal combustion engine into a propeller, for every 10 units of power that you're delivering to the turbine, you're likely to get 1, possibly 2 units of power out of the propeller. Of course, if you deliver that directly to sails and directly to the ship itself, you're getting 100% of that. 10 units in, 10 units of power out. So what does wind actually deliver? Well, it's a zero emissions energy source, and we're talking about the energy source here, not the technology, which is delivered for the lifetime of the vessel at zero cost. So zero volatility in that. It'll be zero at the beginning of the life of the ship, zero at the end. And as I mentioned before, there's no infrastructure there. You don't need to store it. The wind propulsion technology itself, zero development time. Well, what I'm trying to say here is actually that there are technologies already in the market. We have a very robust R&D pipeline coming through as well. So if you want to buy wind propulsion systems for your ships, you can. Zero compatibility issues. This meaning if you choose any other fuel, ammonia, hydrogen, methanol, batteries, whatever it may be, wind is compatible with those. Zero additional crew. We're not talking about going back to the heyday of the clipper ships, although there are ships like that being developed and deployed. But these are fully automated, modern systems, which don't require any new crew. And zero capex, which I put a question mark on here. There are developments where we could be looking at leasing these systems rather than heavy capital expenditure. You move the cost over because it's the only propulsion system you can deploy that's cheaper than the one we already have. So you have a return on investment. So zero capex is possible. And we like to call that a win-win-win situation. With retrofits, we can deliver 5 to 20% of the propulsive energy needed, optimized up to 30. So remember, that's when you're putting wind onto an existing motor vessel and still running it as a motor vessel. With new builds optimized, 50% plus is very doable as primary wind. Of course, the higher percentages will be on the windier routes. And there are 7 different technologies that we're looking at. And I'll just quickly run through some slides. I don't have much time, so it'll be very quick. There's the rotor sail, which is uses the Magnus effect, which is similar to the curveball in baseball. So a spinning cylinder with a small electric motor. The wind hits that, creates a differential on either side of pressure, and that sucks forward the ship. Indeed, that's really the way all sails work. A sail doesn't push the ship, it actually creates a difference in lift, if you like. And just think of an A380 jumbo jet, very small wings, huge body. Those wings generate a huge amount of lift, and simply what we're doing is making those vertical and creating that lift or thrust aspect with those. We have suction wing, which actually has an active suction device inside, so pulling in the wind around the wing itself. Hard wings or hard sails, various different types there. Again, if you've watched something like the America's Cup, you will have seen these deployed, and the ships or the boats are going 3 times the speed of the wind, exactly because of this suction or thrust aspect that I talked about before. Soft sails and hybrid sails. This is well known to most people. Interesting, there are various developments in this. The one at the bottom of the slide is actually an inflatable wing made by Michelin. We then have kites, which are deployed either as a passive system or as an active figure of 8 system, which increases the thrust. And a lot of people would say, but what happens when the wind doesn't blow? Well, at 300 meters, the wind is blowing consistently. Maybe not always in the right direction, but you're not going to lose the kite because of a lack of wind. And these deploy with quite a lot of drone technology on them now. Then we have turbines and also the hull form itself, which can generate thrust by the hull becoming a wing sail. Now, widening this to a wider decarbonization aspect, we adopt the idea of hybrid wave, wind plus activity plus vessel plus eco-fuel. each capturing around 20% plus of the propulsion requirement, either reducing it or delivering that. So reducing that eco-fuel component makes that much more manageable. It's going to be expensive. It's going to be difficult to deploy that worldwide. Wind is already globally available. Now, if we extrapolate that and say, if we mandated all ships, retrofit old ships, all new ships have wind, and we equal that out of, say, around 20% of the fleet, if all the fleet was had wind propulsion deployed this decade, the savings accrued by 2050 would already reach $1 trillion based on a fuel price that's lower than today's. And then increasing incrementally as new fuels, more expensive fuels come in and a carbon price comes in. That 1 trillion meets the IMO target for 2050 of 50% decarbonization, and in fact goes a tremendous way towards the full decarbonization, because wind will have paid for itself and also reduce the requirement for those fuels. So in effect, we could have full decarbonization of shipping with no additional cost, effectively getting it for free. Now, a lot of people would say, well, okay, you've talked a good shop here. Where are we today? Well, we have 22 ocean-going vessels. These are large vessels across the tanker, bulker sector, roll-on, roll-off ferries, ferry crews, and general cargo, and one large fishing vessel. This equals about 1.5 million deadweight tons of shipping already. And as you'll notice, container ships are not here yet, although we have some designs that will likely be tendered for entry into the fleet by 2024, early 2025. This also excludes 20 small sail cargo and fishery vessels. Now on this slide, this is showing the increase for next year. And effectively, we'll be doubling the number of ships within 12 months that we've actually deployed in the previous 12 years. So it's a really large increase in the momentum around the shipping. Some upcoming developments. We have 6 ships in development at the moment or waiting installations. Probably 3 of these will be deployed within the next 3 months, the other 3 in Q1. A couple of interesting ones, obviously the Kite on a Cape-sized bulker, very large ship. We have the largest roll-on, roll-off ferry there, and also the Ariane Group MV Canopy, which will be transporting Ariane 6 rocket parts from France to French Guiana. She's already in the water, but she hasn't got the wing sails attached yet. Just a couple of additional slides. We have the policy pipeline. And what this slide effectively shows you is the hatch line going through the middle of it is the market projections from the UK and the EU governments, looking at around 10,000 installations by 2030, increasing up to 40,000 installations by 2050. We think those are rather conservative. But what you'll see here is that the IMO strategies, the European strategies, and a lot of the non-government programs are really pushing the policy forward, decarbonization, and effectively encouraging wind propulsion. My last couple of slides. One is on primary wind, which I mentioned before. We have a number of these systems being developed for deployment in the next couple of years. The Wind Hunter on the right side is an interesting one. It's actually a climate positive ship, so it will be generating an energy cargo from energy harvesting, because quite often a ship will receive too much wind. It could harvest by counter-rotating the propeller or having drop-out turbines to capture that, to make it into fuel to be used later for the ship when there's no wind. This one takes it one step further and tankers that fuel as well, so it becomes a revenue stream for when it gets to port as well. And my last slide, this is quite a busy slide with a lot of company logos on it. All of these companies, not all of them are members, but all of these companies are engaging with wind, either validating it, testing it, developing technologies, or putting these already onto their ships or planning to. So what we can see is, even though wind propulsion isn't quite mainstream yet, mainstream players are investing hundreds of millions into this sector. And we like, again, to call this a win-win-win propulsion situation. So thank you very much. And if you have any questions, I'm more than happy to answer those by email. Thank you.
All right. So the excuse cannot be you have your questions for him and therefore you're not asking any questions. That is not an excuse. Okay, so we have a few minutes. Who has my 2 questions? Thank you. Come on up.
This is a question for Sushil. I hope I pronounced that correctly. What sort of range are you expecting with the underwater laser communications? And I'm sure it varies with water clarity, et cetera, but just in general, what sort of communication specifications are you looking at?
Right. Of course, it depends on how expensive a thing I put on the prototype, right? You can have things that cost hundreds of thousands of dollars just to prove the point. We are focusing on making sure we say it works, that it transfers data, that the swarm holds together, the data is moving through wireless. For that, what we do is 10 megabits. It's the sort of what we use. It's good till about 10 to 20 meters if it's not a completely murky water. We've been testing in the Port of Long Beach here, which is a nicer water than, let's say, in San Francisco where the lab is. And what we believe is, for the purposes of this particular swarm, because this is a specific use case, I'm not trying to talk to submarines. So for this particular use case, we have probably only 5 of them that can cover the ship, and they are fairly within a few feet of each other. And so this works out. It's a very doable thing, and we have done it.
Can't get to 2. Oh.
Kortney, as far as deployed with your devices, just one question: how deployed are they, and if you have deployed them, can you extrapolate about how much ghost netting you have saved from going into the environment?
I think this, yeah, it's on. So we do have customers all over North America. Like I said, I think we've shipped about 700 buoys at this point, so out with various different fisheries. There has been ghost gear that has been saved or retrieved using the buoys. So that's there's anecdotal ones that we get actual messages from the fishers. Others we do see on our own monitoring. And so I think the more that we get out there, it's about kind of getting that density of, so it's not just about having one or two, people try out 1 or 2 buoys, it's having it on an entire fleet or an entire fishery. That's where you start to see the statistical significance of actually preventing ghost gear. And the other thing, though, that we do look at is the fuel savings. And that's kind of the daily pain point for a lot of these fleets, is how long are they spending looking for their gear? Because again, some of them, it's not so much the gear loss, it's the actual how efficient can I be at finding it? And with fuel costs the way they are right now, that's actually a much bigger financial incentive for them to use the technology. And so that's something that we'd like to track going on as well.
So we hear access to capital already a challenge for BlueTech companies. And now we hear technology companies are all going to struggle with access to capital because of the tightening of the markets. Are you concerned about that as you think about your growth plans?
Yeah, I'll take this. What happens in these situations is that it says a little bit like this, that you have some PhDs who have a good idea, they can perhaps build a prototype, get it somewhere. At the same time, these are B2B plays. These are for the industry. This is not trying to sell at Sky Mall. So what happens is that somebody has to say, this is what I really want, and there's an exit at a certain point, except they are not willing to deal with the prototype. They want something that's kind of commercializable, this at least at the product stage. So the gap exists between the two. It's okay to get accelerator and small grants to get that thing going, but it's a between the prototype and commercialization is the gap where what we hope really is that the ports who want to be part of the green corridor, or some companies, their innovation departments that want to be part of this, that they do put something in saying that this is not just for that financial reason that it's an investment, but it's actually a strategic investment in improving the industry.
I'm going to do a shameless plug for the NOAA SBIR program since they're here. So we've been fortunate to have the support of the SBIR program, and I think we just had our final demo day workshop with them, and I think it's really phenomenal the range of technologies that they support, from all the way from companies that are just forming all the way to ones that have many products out on the market already. And I think it's a great way for companies to try out R&D before it goes, but also support it on the way to commercialization. I do think that, I'll second what you said as well about having strategic partnerships and finding those right customers that can really buy in early on, and whether they can actually invest or be early customers, that always helps as well.
And all of you are using data, which is very cool, and machine learning and sort of advanced data analytics. So in Canada, we have a huge shortage of data scientists, data capability, and our companies are really struggling in terms of being able to hire. Just curious, do you have any challenges from a workforce perspective to be able to achieve your outcomes? If you don't, what is your magical formula, if you're willing to share it? And if you do, what are you looking at to try to address that?
Absolutely. I'll take this first. So here's how I look at it. I'm old as the hills, but I can make an AI program overnight. This is not that big a deal, really. I could get a high school intern. They're going to pull down something from GitHub, and you will have. This is like saying you have an Excel spreadsheet. This is what really is needed is the data. Data is what makes the model. Data trains the model. Data tells where the coefficients really are. If you don't have data, not right kind of data, you just have something that spits out something. So what happens here is that a lot of people will say, for example, in my case, that we will have people say, oh, we have taken a lot of diver videos, or we have ROV-based videos. They're sitting in cloud and they're geolocated. The thing is, they were all taken differently. How an AI program that's like a neural network program, there's simply kind of a black box that looks at a cockroach and thinks it's an airplane because somehow some pixels just kind of matched up. What we're saying really is that if we can come up with a way that you're generating data, what I believe is even now during the field tests, when we are largely testing whether the laser is localizing or not, what we're really working on is the laser is moving through the water, and we're making sure that it's still locking as the things are moving. But during the time we're creating data, keep creating the data in the same standardized way. It goes along the same path. And that kind of a standardized, classified, labeled kind of data, more and more we generate, you develop a better model. I don't think it's so much, I believe, is that you need so much the talent or the human power in it, is the lack of the fact that people keep thinking that somebody programming something is what this is, while it's really the data and having a standardized data.
Well, I respect that opinion too, but from a business team perspective, I guess, talent is critical, even in our business, especially. And I think that the big problem though is retention. But at the same time, maritime is one of the last major industries going through an evolution, digitization. So that talent that is aware, that's familiar, that's experienced, enough to understand the market, but also understand data. I believe that's pretty rare. It's pretty difficult to find. But again, we're in almost an infancy stage, I feel like. So, for the next generation that's in schools that, are data scientists or programmers, et cetera, are they inspired by our industry so that they could take a leap and say, oh yeah, maritime, or marine, whatever it is, I never thought about it because I never really see it. But maybe I have a career in that way. That's my opinion on that question.
And I'll follow with that. We actually have been fortunate to have some relationships with a couple of universities, University of Chicago and Southern Mississippi, that have specialized in maritime data analytics. Because you're right, ocean data it's different. Fishing data is even worse because it's temporally and spatially, it's not what any data scientist enjoys or wants. I guess it's not as constant as they'd like, but there's a lot of insights that you can gain from looking at this, but this also takes a lot of understanding of the industries, and so I think that's where a lot of the challenges are.
Awesome. All right, my last question from my last panel, which is very exciting for me. What gets you 30 seconds? What are you most excited about when you look forward?
I'll go first. I think I'm most excited about all the different sensor technologies that are being developed, all the different the newer presence of things like precision fisheries, smart ports, shipping that has much more intelligence to it that in terms of all of the sensors developed. And so I think we'll see a lot more motion in that direction. I think the challenge is going to be making it global and getting it accessible by all of the coastal communities.
As a former seafarer, I've been on the operational side and I've seen things done the way they've always been done. Very old school, and the mindset has always been whatever, it's always going to be that way. I'm most excited for the future because this is a testament. Everyone that's here understands that there is value in the future in BlueTech and in the marine space. And I'm excited to hear everyone always throw the word partnerships, collaboration. And it seems everyone's on that same page, whereas maybe 10 years ago, everyone was too scared to open up their minds and really share a little information about themselves because they don't know it yet, but there is some synergy. So I'm excited for that future.
Yeah, and as much as it can be exciting to see a swarm of robotic bees shooting lasers at each other, I really think that the fun part of it is to think which are the key ports that create that algorithm through which you can cover almost all the voyages, because you have to kind of say, I can be Long Beach. I don't have to be at all 150 ports. The ships, as they are traversing, I need to catch them only once in a period. If I can be in Singapore, can be in Rotterdam, can be in a couple of other places, I could take a large part of this TAM right there. And that's when coming to this conference, meeting somebody from Port of Singapore, meeting people from Port of Long Beach for that matter, that is the exciting part, that what we are working on, just by working in ocean, you're working on a global thing. And that is the exciting part of it.
Awesome. Well, please join. Question, sure. I'm going to go over time to let you ask your question. Go ahead.
To your point before you closed, when you made the point about access to capital and how it can be key in a company's growth strategy, I just wanted to point out that if your growth strategy includes going globally and taking your product to international buyers, please tap into the resources of the Export-Import Bank of the United States, or EXIM. That's the agency that I represent. We work closely with our friends at the International Trade Administration. And basically, we offer solutions that can help U.S. exporters compete more effectively globally with less risk, more peace of mind. We also offer loan guarantees to encourage the banking sector to finance exports, and also help address the credit needs of your buyers internationally, especially if they're smaller or mid-sized companies. That's often an obstacle to be able to do more. So thank you.
Awesome. Thank you. So someone else to look for if you're looking for help to find markets or money. Awesome. Thank you. Okay, now join me in a round of applause because now I've gone over time for this panel. And thank you so much for asking questions. I really appreciate it. I had my first board meeting at 4:30 this morning, so it's been a bit of a long afternoon, so thank you for helping me out.
And we have another panel coming up. That is the secret add-on panel, I think, and it's about the
Last panel.
security technologies in maritime industry. And all right.